Hello everyone. This is part 3, I guess. I'm streaming it again because I know it's going to be fairly long, and I thought, well, I'd just go ahead and upload it as I do it, because basically my videos are just start and stop. That's it, so I might as well do it live, see what happens. So I just want to just do a follow-up on what I've done so far. Excuse me. About these two linear regulators here. Actually, these could be the. I think these could be the adjustable type of linears here. It was a while ago since I did this, and I've remembered. I've actually remembered a bit more since then. So let's see what I remember now. Right, so they're wired up to do a to do a fixed current. So basically. It's not adjusting the voltage, it's adjusting the current, and so you can stick it, whatever voltage we put in there is what voltage comes through, but the current doesn't increase. And basically there's a formula. Basically what normally goes to the ground here, this wire goes to ground to give it a reference voltage inside, and basically what you do is you work on that reference voltage. You calculate that with the current that you want, and it'll give you, and you end up with the resistance that you need here. So then you end up with a fixed current. So basically, what I've done is I've changed this slightly. I had these resistors, so I've put these on. They could be a little lower, really. These are giving, well, like the ones I've got are 12.5, and it's giving me just over 6 ohms here. But because the two resistors are both 2 watt, we've got like a 4 watt resistor here. So we've got like 6.25 4 watt resistor now. I reckon you can go down to about I'd say maybe 4 ohms in total, but your wattage must be about 4 watts. So you'd probably end up using 2 resistors, 2 watt resistors, because that's what's on. They're the easiest ones to find and buy, basically. So anyway, that's it. So the actual voltage that I am actually sending to the stepper motors, so these little stepper motors, they're actually getting 10 volts. I'm putting 10 volts into these, but because the current isn't increasing, it's better because it's not going to warm these up. Basically, this lot gets really hot down here. Basically, this all the heat and the wattage is all dissipated by these resistors and these regulators. So these stay really cool. And like with most motors, if you increase the voltage, you increase the speed. So and you get a bit more oomph. I mean, voltage, another word for voltage really is pressure. So you're getting more pressure into these motors, which actually turns them faster or stronger, in other words, put simply, basically. So basically in here, the voltage I'm putting here is 10 volts, but because these are current limiting, these are not going to warm up anyways. So I thought I'd just go over that again. And let me just bring it back up again. So that's what I've got there, basically, and the wiring. so these here, you could, I think you can actually use the variable ones as well as the fixed ones. Anyways, that works as it is, so if it works, leave well alone. I mean, I did this quite a while ago. Just excuse me a minute, that's my throat. I'm just going to turn my mic off when I find it. Yeah, sorry about that, I just need to clear my throat a bit. Yeah, so we can ignore that now, so that's done. Yeah, so basically I've put 2 watt 12 ohm resistors here, and also I found out, well actually let's go to my overhead view of what I've got so far now. So what I did, was instead of shortening the original cable from here, it had been on the it was pretty the cheap plastic stuff. Where are we? Don't know where I've done with. Oh, is that it? Yeah, this is it. This is what was on it originally, and basically it's gone a bit hard actually. Not so much there, but here, yeah, it's gone a bit getting hard and a bit brittle. So I decided to remove the whole thing, and I've used the same cable I've used for the stepper motors for the servo. And it makes them all. It makes it all match basically, so it all looks nice now. So this is how it look now. I've got my little knob on top there, and I found out as well, doing my bit of research, what I did before. Can you see there? Let me just see if I can. Let me just bring up. Where are we? Lost it. Yeah. Oh, hold on a minute, I've just messed it up there. Yeah, back soon, don't worry. Let me just turn that off. Well, let's go to my main desktop. So I'll turn this one off. Right. Yeah, it's working here. What I wanted to do was show you. Oh, right. While I've got this big wide screenshot, what I'll do is I'll just make that as big as possible. I just want to show you where my Arduino is. Here's my Arduino with my I2C bus as normal. This is, get rid of all that other rubbish. There we go. We can see it now. So this is my normal board. My Arduino on, my I2C bus, and then I've got I2C cable coming to one of these memory programmers. I've coloured this in because I don't know if you see on. Can you see on the board where we've got that little dimple there? So pin 1's here, and some arsehole has put this thing with the dimple on this side there. I don't know. Can't see for the light, but I don't know if you can see there. But the dimple is on this side, so they've stuck that on the wrong way around, and I kept putting this in the wrong way around. So I've got my nail varnish and put it on there yellow, and I've put a yellow dot on my little memory modules. So this is just I2C cable coming in from my Arduino. You probably won't be able to see my Arduino later on because I'm going to go back to the other image. But I just want you to know this is, like I say, it's just attached with the I2C. It's on there. And I've just put this memory model in here, memory chip in here. I'm going to demonstrate how to how to upload the data to this chip, and they're all set on its default addresses here, so this never changed. We just unplug that and plug another one in. Well, there's two actually. If we look at this, what we can see is what I've done is I've marked with the red, I've marked up that memory 1, and with the red I've marked up this memory 3, and I've got my yellow pin 1 and my yellow pin 1 on the other one. So it only needs them two memory slots plugging in. Yeah, I'll try to switch to this so we can actually get it to zoom in on there. So yeah, what am I rambling on about now? Right, yeah, so that's my memory things. So we only need them two in there. So you've got to unplug them from here and then plug them into this. Let me just zoom in on that. There. So we just plug them in there to program them, and then we put them back into here basically, and they live underneath the little LCD player, and I've put like a little support on this end. I'm sure I've forgotten something else as well, like, but anyways, that plugs into there, and then there's my cable. Just push that over there so it's out, so you can see it all. So that's how it all looks so far. So yeah, my memory was well, we all know my memory's shit. I can't remember what I just said. Yes, so let's start with the Arduino and the code for the Arduino. I was probably started talking about something else to start with, but I think I've just gone down another route now. So yeah, we're going to talk about the code on there. Now I did this a while ago, and as I said, we've got memory chips to store all the information on, because basically I was running out of memory on the Arduino. And when I did this Arduino is one of those cheap Chinese ones. Nothing wrong with them. They're cheap, so they still do the same thing. There's nothing wrong at all with them. It's still got the same chip on there. It's all it is. It's got the what is it? The 350 USB translator on it. Anyway, whatever it is, it has a different USB chip on it. That's all. That's the only difference. Yes, but yeah, I'm just trying to remember. Right, yes. Yeah, so when I programmed this chip had the old Nano bootloader on it, and it still has the old Nano bootloader on it. And let me bring up the software. Oh, I haven't got it open. Right, let me just open it. Let's see if I can find it. LMN. Oh, it'll be up here somewhere. Mini plotter 2 with compact memory. Here we go. So here it is, and it uses the Adafruit libraries, but I put a note in here because it uses the version 1. Now this is because it was a fairly old I forgot, it might be about 5 or 6 years ago when I did this. I don't know when. Anyways, it was years ago. And since then, Adafruit have upgraded their graphics and stuff, and it appears they must have put something more in there, because now if I try to compile this, like I said, it was tight on memory before, and we've come up with an error. And what it is, now why is that? Yes, it's because, right, I changed the library. Well, actually, let's just go and put the library back, because I tried to use this version library and it comes up wrong, because this library is now not compatible with this, so I don't know if there's an early version of this either. So if we go back to Sketch, if we go to Sketches, let's manage libraries, and we'll put the latest one of them in. What do we want? The SS. Right. Give it some time. Right, what we're looking at, SSD 1306 Adafruit. There we go. Where? There we go, installed. Right, so we'll click on that, and I think I put, well, it's got version 1 in there, but that didn't work. Let's just put the latest version in there. There, done, close. Right, so now what I can do is we can just check that now. Now that they've all got the latest. See if we come up with an error. Right, so now what we've got is Sketch too big. You can see it's 7% over basically. What I'd have to do is I'd have to probably take out the Adafruit stuff and put in something smaller, because this is basically the Adafruit stuff is basically for people learning, and it's got a lot of stuff in there that is not really necessary for this project I want. So the fact is, the reason I'm showing you this is because I can't give you the source code. So what I'm going to do is, what I've done, because I had the my original Arduino Nano, it's still got the software on there, and it's only the software that this doesn't need to be changed on here. If we want to put more stuff on there, all we do is we put it onto the memory of these memory modules. You know, these little chips here. These we can just add more stuff on here, and it'll still work fine, because all the changes happens on these little things. So what I'm going to do is press the right button. What I've done is I've backed up I've backed up this the data on this chip. So now I've got this chip, and so obviously I can publish these two, the EEPROM file and the hex file, and I've also done a little text file. And basically what these can do, what we can do with these is I've done all the instructions, and we can use the this AVR dude to just upload them hex files and to the Nano, and everything will be fine. So I can still publish the hex, and it can still be uploaded to the file. Yes, so I think that's what I was going to say about that. It's just these two files. What we need to do now is I need to show you how to program these EPROMs. I had to look this up because I'd totally forgotten what I'd done. Let me see. We can minimise that. Oh no, I'll leave that. Can I bring that up now? No, why is that doing that? Hang on, I'm going to close that. Yeah, it's just thrown a wobbly for some reason. Let's see if that clears it up. There we go. So I've got that back now, and I'll leave that over there in that corner underneath it. Yes, so where was I? Yes, EPROMs. So what we need now is my web browser. Let's turn on my web browser. I don't need that. Have I got my web browser open? Let me just... Can't see what I'm doing. Yes, there's my web browser. So I will just bring that. Excuse me, let me turn the mic off. Right, I think I got rid of that. Yes, web browser. Let's put that up there. And let's make that bigger. There. Right, so yes, I had to look it up again. So if we go to my blog palette, hang about, wrong buttons. Right, I've got that up there. So if I press on that, right. Actually, I need more monitors. I'm going to do... No, I'm not. Am I going to do some... No, I'm not. Hang on. Right. Yeah, I'll do it like that, I think. Yeah. So, we need to go to my my blog place. God, my nose. Blog place, and look at what I did. So if we go here, and this is the thing. Oh, I'll tell you what. Right, you might want to watch this video. Where are we? Not that one. Yeah, this video. You see, this is the sort of thing we can draw with our plotter. Everything here is a 40x40. So you've got like a corner there. That's a 40x40 corner. And you just draw it 4 times in each corner. And this little cube is a 40x40, so you just draw that and that and that. And all these letters are all 40x40s. So you draw each letter one by one. So if you watch this video here, you can see how my original one did it. And our new one is going to do it exactly the same. But I sidetracked there. Yes, so I had to look it up in my memory. So I think the easiest way to do it is actually just read through this basically. So this is the little memory thing. Or at least that one's the right way around. Yeah. So the plot files can be quite large, but what I've done is I've actually compressed them as well. If we look at a typical, let's look at a typical plot file. I'm just looking. Yeah, I think I'm going to work on my desktop again, because this this OBS is great, but I lose track of where I am actually doing things. So for this, I'm going to go on my main monitor. So I'll turn my web browser off, and I'll bring my web browser in. So I've got that. And I'll turn that off as well. I'll leave that up in the corner, because I'll turn that off for now, because we don't need to do that. So basically, the little module is plugged in here. Basically, we just need to remember that. That's all. So I'll knock that one off. So you can see what I'm looking at now here, which is this some files. So like Miss Snowflake. So if we have a look at that, we can see all the code in here. And does it tell me how big that file is? No, let's have a look at this. Right, that file is 4 kilobytes. And so if we have a lot of them, I mean, there's one here that's 9 kilobytes. Oh yeah, 13 kilobytes. Or 22. Oh no, that's a DXF file. But anyways, so we're looking at a plot file. Well, I'll tell you what, let's have a look at this other one. Get rid of that. Yeah, let's have a look at this. Yeah, this is Instructables robot. That. So anyway, you can see all the code for this robot, and you can see that you send a basic G code instruction, which is like GO X 5.9 Y 11.8. To send that, it's using 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's using 13 bytes. So we've got 13 bytes of information, and what I've done is I've compressed that down to 3 bytes. So I've compressed it so it's only this long. It's as long as that. 1, 2, 3 bytes there. So that's what I've done, is I've compressed that all down to just 3 bytes, if you can believe that. So yes, so what I need to do is, where's my, so if I bring my my blog, yeah, so bring my blog here so I can see what you can see there. There we go. Oh, excuse me a minute, I just need to take some pills. Hopefully that'll stop me coughing for a while. Yes, so we're back to here, which is adding memory to the Arduino and compressing G-code. That's what we're going to do today. So we're using this Amtel 24C256. Now that's 256 kilobits. So let's have a look. Yes, the memory is divided into 8-bit chunks, 1 byte, so we can start 32 kilobytes. So that's 32,000 bytes we can store on there, so it's quite a lot really, especially when I've compressed down 13 bytes into 3 bytes. So and I mean, so each byte is then addressed at between 0 and 31999, 32K. So that's okay. So we'll go past that. What we're interested in is how did I upload the stuff. Yeah, I wrote some code. Yes, so I did write some code. Right, so we'll need that as well. Not that one. Where's me? Oh, it's the folder one. Right, so I've done a package. So I'm going to publish a package, right? So this is TGC, which basically it's just G-code files, but it's formatted slightly different for mine. It is G-code, so like you say, if we're looking at the outlines and we look at the what do you call it, the instant there, it's G-code basically, but it's just got a few things missing, like pen up, pen down. We don't need pen up and pen down because we've got the GO and we've got the G1, so we've eliminated the up and down of the pen there by just using either G1 or G0 basically. So G0 is a move command, so that just means the pen will be up, and if it's a G1 it's a draw command, so the pen will be down. So that's one way I've shortened it, which is, so if we go back, and these are all the files that we're going to upload, all the outlines, and I've got all the capital letters. I've done the DX files and the G code. So yeah, so that's all our this is all the stuff we're going to put on the EEPROMs. And we got some special files which we're going to come to, like my memory words. So my memory words, these are all the words all bunched together to save memory of the menu system. So you know, we've got the main, manual, you can see all the words in here, but they've all been put end to end because that's how we're going to store them in the memory. And then we've got, this is just for our notes. This is so like the characters. This has got the ABC, so we know what actually this, because what I've done is I've used the ASCII number for the characters, and I've just done this file so that I know which one's which letter. But we'll come to that in a moment. Excuse me a minute. I don't know what's wrong with me today. Right, so yes, and then we've got our plot characters. So this is what we're going to upload. This, if you imagine how they used to do floppy drives, if you remember floppy drives or hard drives. Hard drives, well, we still use hard drives, but they're fading out. But we used to have floppy drives that's going in front of a computer, and it was divided up into like sectors, and you in the middle of the floppy drive there was actually a partition table which told the computer where everything was, and this is like a partition table for the memory. Basically what it's saying is what letter it is, and it's how many characters long it is, and at what position it is in the memory, and how long it is in the memory. So that's what that is. I'll explain a little bit more later. And we've got the same for the plot names. This is for the actual outline drawings, so we've got something similar. We've got the name there, so like for cube, it knows what the cube is. It knows that it is in memory chip 1, and this is the actual address that its cube starts at. So this is the cube that is going to draw and it knows how big that file is. It knows that it's 156 bytes long, and so if we look at this number and then the next number, you can see that this next number is 156 bytes on from this one basically, and then this one, it tells you how long that file is. So for the snowflake, this is how it knows where the data is on the EEPROM for the snowflake. We've got to put it all there yet, but this is sort of like done after the fact when you've created the files. So, but because I've already done it, we can actually see what I've actually done. Oh God, I hope this is making some sense. Well, I hope it makes some sense later. So yes, so I've done a package, and these are the files. These are the files we've got to use, and we have to stick them onto the EEPROM. So I've gone through a load of stuff here of how I come about actually making and writing the code, and how I've come to shorten these G-code values down to 3 bytes. So instead of, like I said, that's got 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. See, that's got 18 bytes there, and I've cut that down to 3 bytes, and this tells you how it was all done basically. It might sound a little complicated, but it's quite simple really at the end of the day. And what you've got to remember is a byte and a character, when it's actually written on an EEPROM, these are both actually the same thing. It's a number. It's a number written on an EEPROM. It's 1 byte long. A character and a byte is just how it's defined when you're writing code. If you call it a car, a char, or whatever how you want to pronounce that, it's a character basically, and what that's saying is that the value of that byte is an ASCII character. Whereas if we just call it a byte, it'll just read it as a number. Anyways, so that was all what I was saying there, and this I'm going through what all the numbers mean. So this is, like I say, so we've written all the numbers into memory here, but our program needs to know where, like the word manual is there, you see. So when it looks inside the memory for the word manual, so it can show it on the actual display, it needs to know what letters to use. And so this is like our what did I say? I've forgotten it already now. I was lucky. When I was talking about floppies, we have well, it's a bit like a boot sector. It's a partition. Yeah. Well, like it's a map of what's on there basically. So to find manual there, it looks at register 4, and it takes them next 11 characters. Yeah. Sorry, it's manual, because that's manual draw. It's that word there, manual draw. Next, it takes the next 11 characters, or choose plot, and so these we need to tell it where all these are basically. Well, no, actually, it knows where all these are. This is actually part of the program, and this can't be changed because, yeah, yeah, right. So, right, yeah. So this is how we did them. I've written this other software now. So what we've got is I've got some software to do all this. Where are we? Let me just find the software. Yeah, there we go. This is my little my EEPROM writer, and I've tried to make it. It's pretty much designed for this plotter really. It was written for the plotter originally. I've got a couple of commands here which basically that with these you can actually write. These are not going to come live until we're actually connected. These two is you can just if you make a file just full of data, you can just drop it on onto a chip. But I've done this so that it makes it easy to install on a EEPROM. So first of all, what we would do is we would connect. Now, like I said before, what we're doing is we're connecting to this Arduino here. Oh, and yes, this Arduino has firmware on, which I will here it is. Let's look at. I can look at that in the in here, right? This in Visual Studio is just this. It's exactly it's this basically. It's the way I set things up. You can see there it's exactly the same stuff, but I can read it better on here. Yes, this is the firmware for writing for the Arduino. Hang on, let's bring that there. This is the for this Arduino here, which is what we're using to upload to the EEPROM. This is the code that we use on the Arduino to upload. Yes, right. And in this code there we have the setup. Right. So we have the setup here. At the moment, I've got this lot. It's all commented out here. Right, so except for this one, I've left that there so we can read words. So I've left that uncommented, I think, and uploaded. Let me just check that we've uploaded that. There we go. It's definitely uploaded to it now. Eh? So I've got this unchecked. Well, I mean, these are the two important things here. These are workings that I use to do, and all this stuff is what I wrote while I was actually working out how to compress all the data together and get it all onto the memory and upload it. So I've left it, and anybody interested can have a look at all these methods down here and how it's all done. I've sort of separated it, but basically the only time you need to be in here is to uncomment that one or uncomment that one there, basically. So what we're going to do is we're going to leave it at that. Shit. Where are we? Not that. We're going to leave it like that at the moment. Yeah, there we go. Because this one is for programming it's not for programming, it's for checking. It's so we can check that we have written to the EEPROM 1, and this is so we can check that we have written the data to EEPROM 3. So that's all these out. They don't need to be uncommented to actually do the programming. That is set. It's all done. So, but this is so that we can get some feedback and actually see that it has been programmed. So the first thing we need to do is we need to send the words, and so this is basically the memory words file here. So you just browse with this and you go to the memory words file and you select that memory words file. Then we connect. Now you see this has all come live now that we're actually connected, and we need to send this, check that this send words, because that's what we're doing. The reason I've done it like this is because it does these settings for you. Excuse me again, I need to just sort of cough my lungs out again. There we go, done that. Yes, so these are just like presets for this bit area here, so we get them right. So we send them settings to the Arduino, and then we should get a reply from the Arduino saying that it's set address 0, which is what's written here, and it knows that the amount of data we're going to send out every time is going to be 32 bits. 32 bytes, shall I say. So it just confirms that what we've set here is what it's set, the Arduino has set itself to. And then we can actually press this button and then we just send that data, which we do. And we just let that tick away while it sends all that information to the EEPROM. There. So now that it's done, this can expand, by the way. There, look, you can see where it's sent. It sent all this lot. It's just sent it 32 bytes at a time. So if you count all these on a line, there's 32 bytes there. So I'll just clear that. And what we can do, if I press the reset, I'll just press the reset on the Arduino, it'll reset, and because I've got this uncommented, when it resets, because this is in setups, when it resets it's going to run this command. So let's just see what happens. And there you go. Well, actually, this is because I did this before. So ignore that we haven't uploaded that yet. All we've uploaded so far is there. So that is what we've uploaded, and it is put in a list that we can read. Because if we look at that words file, where are we? Memory words file. You can see that it's done it. So we've got the main there, and then we've got the manual draw. Oh shit! There, we've got the manual draw, and you can see what I mean. So basically, what this function does, what this method does here, it basically reads the EEPROM, and then it writes it back out in a format that we can actually read. Instead of bringing it back like that, it actually shows it in a format that we understand and we can check. And these are all the words I've used in the menu for the program. That's what comes up on this little screen here. And these, anybody that uses an Arduino and programs an Arduino will know that text takes up a lot of memory, because each character is actually taking up one whole byte of memory. And so that's why I've got all these words on the EEPROM. So anyway, I hope that explained that. And then obviously we need, although it's here, this plot list, what we need to do is actually send all the plot names. So these are going into a special address. They start at a special address on the EEPROM. It always starts at 500. And the letters are always each plot name is always 15 bytes long, and these are, if we look at here, let's go down and we can read all this. I've explained it. See, that's the first bit that we've done, which is down to there. And then if we look, what I have done is I have created some plots which we will upload, which is all these plots here. And they are all, we follow some rules. Actually, I think I've written the rules in the text. Let's just bring that up. Not that one. We'll read it in here. Oh yeah, rules to store plots. Here we go. Look, I'll just get it right. So I've written it all here. So the rules are that oh, that's about the code, G code. Oh no, that's rules for G code. That hang about then. Where's rules for plot? Let's have a look at this method. Read words. Right. No. Oh. Oh God. Oh, right. I'm sorry. I've lost. I've forgotten where I've written it. I must have written it here somewhere. Oh, is it? Well, I should have scrolled down a bit further. But yes, if we look at a plot name, we've got a cube. What I've done is, here we are. Look, to make it easy, I've made all names 10 characters long. So no matter what the characters are, whatever the name is, it's always 10 characters long. So it's got to fit inside 10 characters. But most of them characters, like you see cube is only what 1, 2, 3, 4. It's only four letters long, but the rest are all spaces. Yeah, it'll be made up of spaces to make 10 characters long. It's like a rule. So each one will has space for the name of 10 characters. Then we have one byte to say which EEPROM it's on. And then we have 2 bytes because it's more than 256. We have 2 bytes to store the address on, and we have 2 bytes to store the length on as well. So we've got 2, 4, 5, and 10, which makes 15 bytes. So each plot requires 15 bytes. The page length is 15 bytes for each plot, and we start at address 500. So we're going to do plot names. So basically what we do is we go to browse here, and then we've got plot names here. So we take that one, and we'll have a look at that. So I did it somewhere here, didn't I? Plot characters, plot names. There. So this first one here can be up to 10 characters long. Then this number here is just 1 byte, so this can be 1 to 256. This next one is 2 bytes, so what is that, 1024? No, yeah, no, what's 2 bytes? Where are we? There's my calculator. I can't remember. I don't try to remember. Here's a calculator. Let's have a look at a calculator. Here we go. Programmer. Let's go bin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There. It can be a number up to 65,535. That's why I couldn't remember it. It's a right stupid number. Right. Okay. Who wants to try and remember that? Where was we? Yeah, so these 2 numbers, because they're 2 bytes long, 16 bits, they could be anything from 0 to that number there, basically, which covers the 32,000 bytes that we have on an EEPROM. Okay, so we're good there. So that's what this looks like, and that's what we're going to upload now. So what we've got to do is remember to set the preset, we set the file, and we have to send them settings. Let's clear this. We send them settings to the Arduino so that the Arduino knows where to put this file that we're going to send to it. So then we just press send and let it send it, basically, and off it goes. They all go to the EEPROM. Yeah, so that's what we've just sent, basically. So we've just sent that. That's it. So we sent a cube, snowflake. These are all the plots that I've compressed and made that we're going to upload to the EEPROM, which is going to be the slow and boring bit, actually. But all this is doing is just telling the it's what it's doing is it's putting the information on the EEPROM that the Arduino can read to find the file that you've chosen, if that makes sense. So when we go through the menu, this information is used. So the name Snowflake, when you go through the menu and you choose Snowflake, it will then read this next bit to start find out what EEPROM it's on, and then it'll read this next 2 bytes to find out where the data for that plot starts, and it knows to read the next 690 bytes to plot the data. Yes, hopefully that was okay. And obviously, because we're in the because we've got the where's the Arduino code? Because we've got this uncommented, and so if we reset the clear that. Oh, right. No, I've missed something. Now I'm doing this sort of backwards, basically, because this information here is not known to us yet until we've actually uploaded the actual files that it's going to read. What you've got to remember, the thing is, I've done this already, and it's all ready for you to upload. The information's all there, the files are there, but if you want to put your own plots on there, you have to put your own plots on first, and you have to make a note of where you put your plot. So you have to know where it starts and how long the plot is and what you've called it. And what you do is you make this file up. So basically, let's say that I want to put all these plots onto the EEPROM, which will plots start at 3000 onwards. You would put cube on. It's on memory. It's on the EEPROM 1, and the first one you've uploaded starts at 3000. So what? This is when I come to compressed code here. So what you would do is you would upload that cube until it's finished uploading, and you will have this number. My program will give you this number here. So this number here will be given to you, and then you would then make a note of it here. And then you would upload the snowflake. Then you would upload. You would write in the 1. This is the address it started at, and this is the length it gave. And then you do the next one. This is the address it started at, and this is the length it gave. And you would create this file. Yes, you would create this file while you were uploading all these plots, because these plots we haven't uploaded them yet. I've sort of gone backwards. I've uploaded these files. What I should have done is I should have done this words first, then I should have showed you how to send the compressed code. So yes, so even though I've done the names, what we can do is I can clear that. I will reset the Arduino, and as the Arduino starts, it then lists the files. But before we did this, what we needed to do was tell it how many plots there were. Oh, hang on, shit. Yeah, well, I'll stay here. Right, so I have to read this and remember. That's the rules. Somewhere here it says, oh right, yes. So once we the names, we need to send a number of plots. To end the number of plots, increase this number by 2. There's something I need to fix. I haven't got a clue what I had to fix. I don't care. It was something back years ago, but basically we need to add 2. So yes, so basically once we've done this and we've created our file, so we've got 1, 2, 3, 4, 5. Oh well, we've got numbers here. I forget this one. We got 23. We got 23. That's my last plot file. 23. So add 2. That's 25. So what we need to do is, I'll bring that back. Yeah, before we do this list, what we have to do is put that number in there. So I'll just clear that. So what we have to do, we need to click on this one here. We enter the number in here. That's how many plots we've got. First we send settings file. We always send settings before we send something. So the number of plots is put in this address. It's always put in that address. We can have up to 256. You know, it's 1 byte basically, so we can have up to 256. So I think that's enough plots to go on the. I don't think we'll get 256 on there. So I've only allocated 1 byte. So there, the page length is 1. So once we've sent that, then we'll just send the number of plots, and it'll come back. It'll tell us, yeah, it's done that 25s. And it's just saying that we have to remember when we do something else, we need to change these. So yes, that's what we had to do. Like I said, I'm doing it back to front now. So what I should have done first, I showed you first, was just send the words. That is just for the menu system. That never changes. That's for the program to work. That's on the Arduino. The code, which I've only got a hex file for now, basically. Well, I've only got a hex file that works at the moment because the other one's too long now for some reason. Some of Adafruit's libraries have changed. So what you do is you put that up, and that would make the menu work. Let's have a look at that. Yeah. So we have an idea what we're talking about. I'll just plug it in, and yeah, and although that I've written on underneath or somewhere on here, sort of like 6 to 24 volts, it's actually about 10 to 12 volts. We can't go above 12 volts because the linear regulator on the Arduino can only take 13, so don't go above 12. Even though the linear regulators that I've put on, they'll take something like 30 volts. But the Arduino one won't. What you'd have to do is take the Arduino out and change the regulator that's on there. I should have really wired it slightly different, but anyways, it's done now. So 10 volts is about okay. You can take it up to 12. So have I got power turned on? Yep. So yep, lights up. We've got a nice bright one here. I've changed the resistor on this. It could be a higher resistor on for the LED there. It's a bit bright, but hopefully you can see that we've now got. Let's see if I can zoom, focus that. That looks a bit better, doesn't it? Let's try again. Yeah. So if I put my hand over there, that's better. Right. So it starts with that, and then we've got the menu. Let's try and get a bit closer, shall we? Try and zoom in. Focus. Yeah. So yeah. So you just move the knob backwards and forwards, and you can choose the stuff. If I press reset, what reset it does is it sort of puts these into 0, like that, and we've got manual draw. So all these names you can see on there, all the names. So if you're clever, right, and you've got a different language. Where's plot names, character, memory words. So you can see, where are we? There, can you see where it says manual draw? If you can fit your own language in where it says manual draw there, you can change that to whatever word you want. And so, because that's where it's getting that name, that word from, is from that what we've uploaded to the EEPROM, and we just click on that. Then you can either sort of like move or draw in a direction. So if we just press the X and I press that, then we've got the move. I've put some LEDs on so you can see it actually move, and I like LEDs. And then the position is up here, so we move at position X9, so 10, 11, and then I think we can just go a bit quicker. And then you can either do, if you use the draw one, what it does, see if I can just get that round there. You see my servo. If I press the draw one, it will just drop the thing down, and then the pen's down when we're drawing X, and so on. Then also, what we've got, if we go back, the speed, we've got settings down here, and if we click on settings, you see you've got speed, servo and laser. So if you set it to laser mode, what it does, it uses its auxiliary pins, and you can control a laser with it. If you got it on servo, then it controls the servo. So we'll just leave that, and we'll just go to speed. If we press speed, you can see that normally I'd take it down to 3000. At 3000 I find is the better speed. It behaves. Above 3000 it tends to miss a beat here and there, and you end up with a piece of crap. So all you do is just press OK, and then you can just move back. And then what we can do is we can choose a plot, and we're going to choose a plot, and then we've either got outline or text. If we go to outline, and then there you see the cube, snowflake. These are all the words that we have here. These are all these words, and this information, obviously, before we can upload this, we have to get this information, and I will now show you how we actually get this information, because we've actually got to actually load the actual plots up to the EEPROM. So I'll just unplug that. Let's focus on it so it doesn't look like a blurry picture. So we're still on EEPROM 1 at the moment. All that's on EEPROM 3 is the alphabet and symbols, EEPROM 1 has the main menu, and it has the plot names and the plots as well. I think I left EEPROM 2 blank. I never used EEPROM 2 because I hadn't filled EEPROM 1 up yet with plots. So let's go back to my program. So we put the number of plots, and let's clear all this. Yes. Oh, let's just go back to the Arduino again. Oh, Arduino code. So that's all this does here is actually well, all that does this one is once you've uploaded what we have, that just I'll just reset the Arduino again. That what that does is just reads all this information and gives you the feedback. All this is read off the EEPROM, so that you can check that it's all been put on the EEPROM. So what we can do is we can remove that once done, and we're happy with that. So I'll save that, and then I'll just not that one. That one, I think. Yeah, so I'll just upload that, and then it won't give me all that feedback now. Oh, what have I done here? Oh yeah, it's because I'm connected here. I'm connected with this. Obviously you can't have two things connected. I'll DC and then upload. Right, yeah, so that's done now. So if I just if I clear that and I reset, if I reset my Arduino now, oh, I am connected. Right, if I connect now, basically it won't come up with that crap anymore now. Well, it's useful information. There, all it does now is say connected, so it doesn't do that when I reset. So now what we need to do is we need to upload the actual plots themselves. These are these files. So what we do, right? So we've got numbers, lowercase, capitals, and we've got symbols. But with outlines, these are the actual. So we've got I've numbered them to make it easy. And what we've got, like cube, snowflake, wolf, lynx, witches on a witch on a stick. Anyway, you get my stuff. We get my gist. So those are those. So I'll just bring that back like that. Reorganize things. Right. So we've got them up there. So what we have to do is we need to compress code and upload it. What I mean is we have to compress it because bring that file back there. Right, if we look at the cube, you can see that it's normal G code. We've got all this. It's not each command is not 3 bytes. Each command is God knows how long, basically. And also our bytes are to 1 decimal place as well. So it's 20.1 there, you see, and we all know that you can't have a decimal byte. Bytes are just integers. So we need to convert these to integers as well. Need to convert them to integers. What happens is the code, it multiplies this by 10, so then you end up with 201, and then it converts and mixes that with the bytes and then crunches it down into just 3 bytes. I wrote how it's all done basically. So yes. So what this does, when we choose, we go to this file and we go to outlines. Let's just turn that on to Tim's G-code files. There. So when we choose the cube, we're going to upload all these, except for rows. All these up to 23 there. These are there if you want to have a go at doing it yourself. But at the present time, we're only up to 23 here. So it's 1 to 23. So you got to repeat this 23 times to get all the plots on. So we choose the cube. So we've got the cube chosen here. We've got compressed here. Now, if we go back to our my blog, we can see what have I done? There's a rule, right? So our compressed codes has a starting address of 3000. So this is where we have to start. Everything before 3000 is to do with names and the actual menu. So we can't save anything before the 3000. We've used that up already. It's all been allocated for other things. So what we have to do, we have to change this to 3000. This is on our first one, and we always have to write where we're going to start. And then we have to send them settings to the Arduino so it knows where it's going to start and its page length. Well, as I've told you, we're converting all that all those G-code commands into 3 bytes, so the page length is 3. It doesn't change. So we're doing the compressed code, which sets this page length to 3, but we need to do the address because only we know where the size of the file. So we've chosen cube, the first one. And we have to do it in this order because that's the order that we have made. Let's bring that back. That's the order that we've made this list. So we need to do it in the order of this list. So our cube's going to be the first one. Now, when we first do this, we know we're going to start at 3000, but we didn't know this length. So what we'd do is we'd do the cube, browse to the cube, we'd send our start position, so we send our settings, so our start address is 3000, page length is 3, and then we'd send our plot. And basically what this is doing is reading each G-code command line in blue there, and the one underneath is the 3 characters that it's sending. So it's reading this code and it's sending them three bytes. It's converted that code there to them 3 bytes there, which is, these are actual bytes. So those numbers are actually, each number is just 1 byte long. You can see there, because a byte can be up to 256. So you know. Each one of those will fit into 1 byte, and that's where it's converted that into there, you see, into that 1 byte. And so once it's done that, and it sends it all to the EEPROM, and it started at this address, and as it sent each byte to the EEPROM, it kept a count. So it's counted up to 156, and so that's the number we need to put here, 156. Because that's how long it is. We got the first address, which was the 3000, and now we've uploaded it. We know how long it is because it's counted how long it is here. So we put the 56 in there. So for the snowflake, when we load the snowflake, we have the snowflake. we need to set it to this address here, 3156. Now I've put a little, rather than have to type it in there, I found it a pain to keep typing these numbers into this thing here. So what I've done is, if you double click this number, it will stick it in there. So double click this and it'll put that number to whatever number this is here. And so all we have to do then is just send the settings. So we send the settings. So we now, the Arduino now knows that when we send the snowflake, it's going to start at this address, and each one's going to be a page length of 3, and so it's going to count them up as it goes. So we can just send that, and if you watch the codes come up here, you'll see underneath that the characters that it's actually sending, because it's sending it's talking to it in characters. So this is what it's actually sending here, which equates to an actual number. These are just 3 bytes. These are what it's read, and this is what it's actually sent. And so it's converting each line of G code into 3 bytes and sending it and saving it on the EEPROM. Like I said, this file here, we didn't have it until we've actually done this, sent the compressed code, because it's these numbers that we need to find. So if you actually draw your own little sketches and drawings and things, and you create your own G code, you can upload it, give it a name, and then you can upload it and find out how long your little drawing is. So you can see now it's done, that it's 690 long, and so then that's what you would enter here, 690. This was from the previous one, which was 3000 plus 156, so we start at 157, and it's 690 long, and so on. And so for the next one, what we would do is I'd double click this number again, so that sets the start of our next one. We'll pick our next one, which is this one, number 3, Wolf. Send our always remember to send your settings before you send the file, otherwise the Arduino will put it in the wrong place. So just confirm that you're in the correct starting point, and then send your file again and send your next. So you do that for every one of these files here. Okay. And then once all them files are uploaded to the EEPROM 1, that's the EEPROM we're currently doing, which is this EEPROM at the moment. So once they're already uploaded and you've done every file, you can see that one's a bit longer than the rest. Yeah, it's done. You see, that one was 600 long. So then that 600 you would then add to the length of that, and then again we double click this to reset our starting point, because that's 600 on from the last one, which is there. So that's our starting point, and then when we upload it, it will give us that length for the next one. So right, I'll leave that as it is because it's gone on long enough, and this has been a really boring video so far. But there's also now the actual characters. So we have this send plot characters. This one here is this one. Now for the characters, what I've used as their names is the ASCII value. If I look at, do I have one up? If we have a look at the ASCII chart, you can see here, let's go to the beginning, you can see that 65, if we go and find 65 here, 60, you can see that it's a capital A, and then 66, 67, so on. And it goes down to 99, 100, And then you can see I changed here. I've gone down after I got to 122, which is 122, which is the lowercase z. I changed to 48. If we go across here to 48, you can see I then started putting the numbers in. So if we go 48, that will go up to 57 for 9. So if we go to up, and you'll see at 57, now I change to 33, which is where I start doing the symbols. You can see the decimal value there, 33, and then we've got the symbols. They will go all the way up to 47. 47, then we jump to 56, which is after the numbers, because I've already done the numbers. Hang on, what are we on about? I've lost what I was doing now. Right, 47. Yes. Oh, 58. Sorry, 58. Yes, there. So the symbols continue on at 58 onwards, all the way to 64, which is there, and then I went on to 91, which is back here, 91. So there's more symbols. Continues from 91 all the way up to 96. And then you can see that there's 4 more around the 123 and 24 for the rest of the symbols, which if we look at this 123 down to 24, 25, obviously delete isn't on there. We don't have a delete character, do we? Yes, so that's just, so this is the file that, like we did for plot names, where there's actually a name there. With the plot characters, it's actually a character number, which is the ASCII character number, because trying to write the names for these symbols and stuff would be a bit more complex. You know, I have no idea what you call these things anyway, so that's why I went for the decimal numbers here instead. But to aid us understanding which is which, I have this text file where I've added the characters. Now this file does not get uploaded to the EEPROM. It is this file without the actual character names on. This is just for the humans to understand what these numbers represent here. This 97 represents an A. If we look at 97 on here, you can see it represents a lower character A. So this is just for us humans to read, whereas this is for the send to the EEPROM, because it doesn't need to know what this number is. It just reads that number, and when it wants to print an A, basically. Right, so yes, so we do basically pretty much the same here. What we do is, this is going to take forever for you to upload because there's that many, but you don't do a number of plots this time. But what you do is you plot each character up, because if we look in our TC, so I've got my capitals, and so we've got an A there, so that's the code to draw an A. So that still needs to be uploaded to the EEPROM so it knows how to draw an A. So what you would do is you would have it, so you would have it on compress again, because it's still just a compressed file. It's still a G-code file. It's going to get compressed. But what you would then, but this time you would have in here is the EEPROM 3. It all goes on EEPROM 3. Does this stuff? So we swap out the EEPROM and put EEPROM 3 in there. Once we have EEPROM 3 in there, what we need to do. Right, yes. Okay, so once we have EEPROM 3 in there, it's no point in reading this because I never had the alphabet when I wrote this, and so there's nothing here about the alphabet, and so it took me a little while to work it out, but yes, it's all on EEPROM 3. The send plot characters starts so that the file, where are we? What we need to do that is change that to text. Go back to the plot characters. This is that one there is the human reading one. This one here is the one that gets uploaded to the EEPROM, so we need that one. We need to send plot characters, we send the settings, and then we send the plot characters up. So that's going to do all the what did I say? It's not the bootstrap. Well, it's like the partitions, the sector. It tells the Arduino where all the characters are in the EEPROM, basically. So basically here when we look at it, it's going to tell it tells the Arduino that character 126 is in EEPROM 3, and it's oh, hang on. Let's open that up a bit. There, it's so we've got character 126 is going to be on EEPROM 3. It's going to be at that address, and it's that many bytes long. So that's what all this is doing, and this all starts at address 0. And what we do is, yes, the way I found out is because I already had this. I already had this document done. I've done the same thing as before. If I looked at the not that one plot character, if I looked at this document I'd already written, I can see that for the actual the plot characters start at address 1000. So what we do is, when we're creating this, well, it's already done for you, so you can follow this one if you want the capitals. So far I think you understand. So we've got a compressed code again. Let's clear all that out. We've got a compressed code again, and then we need to start at 1000. We send that setting. So basically what we do now is when we go to our we're starting with the capitals, which is 65. Let's just go change that. Which A is 65. Now, what I did was I created another one so we know that what we're saying there. Look, so I've put these numbers on so I know what 65 is. So we can see that it's an A. So we start at that one. We've sent our start address, and then we've chosen our A, and we then send, and that sends it. Well, it compresses all the G code and sends it. Then we've got our, it's 87 bytes long. So our B is going to go at 1088. So if I double click this, that'll change that. I can send that setting, so 1088. Then I can go and browse to my B, and then I can send that, and then that'll send that one. And basically you've got to go through all these, every one of those, to get all your data for drawing all the alphabet on there. So I think I'm going to leave it at that, and then what I'll do is I'll just, well, actually, you don't actually need to see me drawing this. From this now, basically, once that has all been uploaded, oh, I got a biscuit. Once all that has been uploaded, let's find them. Let's see if I've got a piece of paper. All right. Yeah. So once that's all been uploaded to the EEPROMs, and the EEPROMs have been placed inside here. We don't need the EEPROM 2. So we've got EEPROM 1 and we've got EEPROM 3. The 3 is the one with all the alphabet on. Let's get a pen. Right. Oh, well, actually, I'll put power on first, because what I find is if we put power on, there we are booted up now. Let's just see if we can get that focused, but get some decent light in there. Right. What I'll normally do is if I go into the first one, manual mode, and we go to, let's just raise that up a bit. If we go to one of the drawers, right, so if we go to a drawer, what you'll see is you'll see that the pen drops when I press the button there. So the pen's, so we're in the down position now. So what I can do is let's just focus again. So I'll leave it in drawer for the moment, and then what I'll do is I'll get my pen, and what we can do is we can set the pen in there at the right height. So I'll just nip it so that it's just touching the paper, and then I'll just push it down a little tiny bit more, so that we've actually got a little bit of pressure there. And then what I'll do is I'll come out of drawer and go to move, and it'll lift the pen back up. So now with the pen back up, now I've left the X and Y the same as the original. So this is actually the bottom line. This is X going this way. Let me draw. Where's another pen? Pen. Well, can't find one. Oh, here's a bit of one. So basically our X, oops, shouldn't have done that. Our X, no, that doesn't work now. Can you see that? X is going that way, and now our Y, oops, our Y is going, oh, I can't see that either. I've knackered that pen. Right, it's, Y is going up and X is going that way anyway. So this is our 0 point now. So everything's going to get drawn inside that. So if I go like that, let's just put that back. I need my glasses now. Let's go back now out of that, back to the main menu, and we go down to choose a plot. Oh, are you going to actually see this? I don't know if you're actually going to see this. Anyways, oh yeah, and what I'm going to do is go to settings and make sure that I am set at 3000, and go back, and then choose a plot. Well, let's write my name, right? So let's go to text. So I've got a text, and we go to, first one is capitals. like I say, it's best to watch the my old videos, and we'll go to a T there. As soon as I press T, it's gonna. Oh, I'm out there. How's that? Is that better? Let's hope for best. Yeah, so we'll try that, shall we? So as I press, there we go. There you can see it drew sort of the T. Let's try and do an I. I've forgotten where I had that. Right, so scroll, go back, and we'll go to lowercase and pick an I. Is that I? Yeah, that's I. Just move it along, and I'll do an M. There we go. There we go, and there we go. Well, Tim, what I tend to do is I usually put myself a little ruler down and just put this along the edge, and then I can slide this along the ruler, and that'll keep the it'll keep the letters at the right height then as well. Or you could actually put some faint pencil lines for you to follow, to get to guide where you place it. But basically that should be it. So I'm going to leave it at that. And what I recommend is if you go back to this go back to me original blog, start with there. It starts there. There's my blog page. What I'll have to do, I'll tell you what, I'll put a link to this in the in the thing below. What have you? Anyways, you know what I mean, don't you? You watch enough videos. Yeah. So it was a bit boring, was that? But I thought it was necessary just to go through it so that if anybody wanted to make one, they knew how to upload the memory. I haven't done a well, I've got this blog, but I haven't done one of the latest version of where are we? Let's bring that back up. Where is that? There, yeah, there. I haven't actually done one of this with this PCB I got from PCBware yet. So what I'm going to do when I get to it is I will do like a blog at PCBware, and I'm going to put it all up on my GitHub. Once it's all done, so you'll have all the files for the 3D printed parts, all the files for the PCB, and everything. So it's going to take me a while to do this, so it is to come, and I am going to do it, but it's not going to be pretty instant, if you know what I mean. So give me a little time to do it. Okay, so if you watch this and you've been bored off your socks, sorry about that, but you know, it's one of those necessary things, and I'm rambling again, aren't I? So if you made it to the end, go make yourself a cup of tea. Anyways, I'm going to stop it there. I'm going to stop chatting. I'm going to find the controls and stop streaming. Bye bye for now.